Okay, we'll solve this numerical. What is, so I read the question, what is the value of force P in the system shown in figure to cause the motion of 500 Newton block to the right side? So direction of motion will be towards right side. This is direction of motion. Assume pulley is to be seen. So whatever this pulley is there, so that pulley we have to assume it as a smooth pulley. So due to this, the tension on this string as well as this string, so that will be same. So because this pulley is smooth, so tension on both the side will be same. And coefficient of friction between the contact surfaces is 0.2. So there are two contact surfaces. So let us name this as contact surface 2 and this as contact surface 1. So coefficient of friction is only one value is given, so that is 0.2. So for this both the contact surfaces, so mu here will be 0.2 as well as mu here, so you can say mu1 as well as mu2, that will be equal to 0.2. okay, so using the free body diagram, so we have to first draw the free body diagram of the block of this 750 Newton. Okay, the methodology of solving this numerical will be drawing the FBD of this 750 Newton block, determining the tension in the string T, and here using that value of T determining the value of P. So if we see in number of terms of unknown, if we see in the terms of unknown, so that will be here 1 and 2. So tension and here friction force and normal reaction. So here one unknown and here one, so only two unknowns are there. Again here force P, tension, and here the reactive force. So here three unknowns are there. So first we have to solve the free body diagram of 750 Newton block. So drawing the free body diagram of that block, so it will be like this. So tension, that will be one of the reactive forces, tension T. Then the weight of the block, now the weight will always act in a vertical downward direction, so that will be 750 Newton. Then the normal reaction, that will be perpendicular. So here we have named it as contact surface 1, so I will name this reaction as N1. Now when this 500 Newton block is moving towards right side, it is given the question itself. So when that 500 Newton block is moving toward right side, so this 750 Newton block will move upward, so this will be the direction of motion. So friction force will be opposite to that, so that will be, we can say, towards left or downward. So F, so again fundamental property, F is equal to mu into N. F limiting frictional force is equal to coefficient of friction 0.2 multiplied by the normal reaction. So here F1 friction force at this contact surface 1 will be equal to 0.2 into N1. Now again, so angle of this surface, angle of this inclination of that surface with the horizontal is given as 60 degree. So I can show that angle here. So that will be angle of between the normal direction and the weight component. So and here this angle again 60 degree. Simple logic is that here if I draw perpendicular, so this angle is 90 degree, so this angle is 30 degree. Again here this is 90 degree, this angle is 90 degree. So if I draw a line here, so this is 90 degree and this 30 degree, or else this we can say 90 degree, this 30 degree, this again angle again 60 degree. Okay, or we can say this angle, so 60 90, so this will be 30 degree. Angle of N1 with horizontal will be 30 degree. Or if we draw vertical line here, so angle of N1 with vertical line, so that will be 60. So here W, for this W, it is the vertical line. Okay, so then this weight 750 Newton, it will resolve in these two parts. So that will be, one of the part will be here and one of the part I can show it here or here also. So I will show it here. So that will be this part 750. So we can 750 sine 60 degree, and this component 750 cos of 60 degree. Okay, so that will be the free body diagram. I hope you have understood this free body diagram. I will explain once again. So when this 500 Newton block is moving to the right side, this 750 Newton block will move up. So friction force will be down, normal reaction perpendicular to the surface, weight vertically downward acting, and that weight component, so it will be resolving these two parts. So that weight, it is inclined at 60 degree to the perpendicular reaction of that surface. So that will resolve into two parts. One will be perpendicular to the surface and one will be the parallel to the surface. So that will be 750 sin 60 and 750 cos 60 degree. And this T of course will be parallel to the surface. Now here this line of string parallel to the surface. So here again T will be parallel to the surface. So using the condition of equilibrium for this block, using conditions of equilibrium, so first condition, algebraic sum of horizontal component of forces is equal to 0. So using this condition, so now here, so summation fx, so horizontal component of forces in the equilibrium unit, we have seen that x is for horizontal. Now here horizontal, so we will assume that horizontal means you can say forces parallel to the plane, or you can say forces along the plane. So whatever forces which are parallel to this plane or along the plane, we can say that that will be the x direction. So simply I can show it here. So this will be the x direction and y direction will be forces perpendicular to the plane. So this line perpendicular plane, so this will be the y direction. Okay, so x will be forces along the plane or forces parallel to the plane, and y will be forces perpendicular to the plane. Okay, so therefore summation fx, using this condition, summation fx is equal to 0. So that will be forces along the plane is equal to 0. So we can say T, again this is positive x, so T rightward, therefore positive, minus 750 sine 60 degree minus F1 is equal to 0, is equal to 0. So we can write in terms of T, so that will be T is equal to 750 sin 60 degree. This negative, when it goes to the right, it becomes positive. So T is equal to 750 sin 60. Again this minus here, it will become plus. So for F1 I can write 0.2 N1, so 0.2 times N1. So I can name this as equation number 1. So again using the second condition, so that will be algebraic sum of component of forces which are perpendicular to the plane. So this is our y direction. So Fy0 means forces which are perpendicular to the plane is equal to 0. So that will be N1. So again this is positive y here. So N1 is upward. So N1 minus this component, so minus 750 cos of 60 degree is equal to 0. So 750 cos 60 is equal to 0. So again solving this, so we get N1 is equal to 750 cos of 60 degree. Okay, so please pause this video here and go on the calculator and solve this 750 cos 60. So what value you will get? So I'm solving it on calculator. So that will be 375 Newton. So value of N1 will be 375 Newton. So putting this value in equation number 1, so value of T will be equal to 750 sin 60. So that will be that will be 649.52 plus 0.2 multiplied by 375. So value for tension will be equal to 724.5 0.519, so I can write it at 519 Newton. So that will be value of force tension in that string. So next we have to draw the free body diagram of the 500 Newton block. So drawing free body diagram of 500 Newton block. So drawing the FBD. So this is 500 Newton block. It is resting simply on a horizontal plane. So directly you can draw the its free body diagram. So it will be like this. So active forces, force P acting at angle of 30 degree, its weight acting vertically downward, 500 Newton, tension in the string T. So again this T we have already calculated, so that will be 724.519 Newton. This directly value we are going to use here, because the question is given that assume that pulley is smooth, so tension on both the side will be same. So when we solve the FBD of this 750 Newton block and we find the value of T, so that same value of T we can use here in the FBD of 500 Newton block. And the reactive forces, so reaction, so that will be normal reaction at point 2, and the friction force. So again this block is moving towards rightward. 500 Newton block is moving towards right, so its friction will be towards left. So I am showing a leftward friction force here, F2. So that will be 0.2 into N2. Okay. So again we can show the resolved component of this P force. So that will be here P cos 30 degree, and here P sine of 30 degree. So again using the condition of equilibrium, so again using conditions of equilibrium, so that will be using first condition, summation fx is equal to 0. Now here directly this is the x direction and this is the y direction. This is positive x and this is positive y direction. So whatever forces are in this direction will take it as positive in this summation fx. So that will be P cos 30 degree minus T minus F2 is equal to 0. So P is unknown, so we can write in terms of P. So that will be P cos of 30 degree is equal to, so I am putting the values here. So value of T is 724.519 plus again F2 we can write it as 0.2 into N2, 0.2 times N2. We can name it as, again let's say equation number 1, because it's a new FBD. We can start numbering of equation again. So that again using second condition, so algebraic sum of vertical component of forces, so that will be this y direction is equal to 0. So that will gives us, so N2 minus 500 plus P sine 30 degree is equal to 0. So again here you can solve it in different ways, like these two equations can be solved simultaneously, or you can put value of N2 here. So, you can use any one of the method. I am doing like this, so you can write in terms of N2 is equal to 500 minus P sine 30 degree. So put this value of N2 in equation number 1. So I am solving that equation here. So that will be P cos of 30 degrees equal to 724.519 plus 0.2 times 500 minus P sine 30 degree. So solving these equations, you can write P cos of 30 degrees is equal to 724.519 plus, so 0.2 times 500, so that will be 100 minus times, so 0.2 times p sine 30, so that will be 0.2 times p sine of 30 degree. So again value of p we can take it as common, so that will be p cos of 30 degree plus 0.2 into p into sine of 30 degree is equal to, so that will be 824.519. So again we can take p common here, so that I am writing here, so p into bracket cos 30 degree plus 0.2 sine of 30 degree is equal to 824.519, or value of p, so that will be 824.519 divided by cos of 30 degree plus 0.2 sine of 30 degree. So answer for force p, so that will, so when you solve this on the calculator, you will get answer for p as 853.5168 Newton, or you can write it as simply 853.52 Newton. So this will be the final answer for this. So once again I will revise the solution. So first understand the question itself. The question it is asked to determine the value of force P that will start the motion of this system of this 500 Newton block toward the right side. So assume pulley is smooth and the coefficient of friction is given 0.2. So we have to draw the free body diagram. So again in terms of unknown, the 750 Newton block FBD will contain only two unknown, T and this reaction, and whereas 500 Newton block will contain two unknowns, so this P, T and this three unknowns. So this cannot be solved directly. So first we have to solve this 750 Newton block FBD, and we can determine the value of T here. So using that value of T, directly use that value of T in the FBD of 500 Newton block second block, and again using this value and the condition of equilibrium, you will get the answer. If you have any doubt, please comment it on the comment section and I will try to answer that doubts.